So now you may be wondering, where does that fatty acid go that we broke down from the triglycerides? Well, it actually undergoes beta oxidation. So what does that mean? That means that it's going to be fully oxidized into acetyl-CoAs, and the acetyl-CoAs are going to go into the TCA cycle, yield us NADHs and FADH2s, which are going to go into the electron transport chain and yield ATP. However, through oxidation, as we're going to see, we also yield NADHs and FADHs too, which will also go into the electron transport chain. So what is our first step? First, we have to activate the fatty acid. Activating the fatty acid means we're going to be adding a CoA group at the end, making it a fatty acyl-CoA. This is going to be catalyzed by fatty acyl-CoA synthetase. Looking at the name of the enzyme, synthetase, we get a clue as to what we need. We need ATP to make this reaction happen. This is also called a thiokinase, and a kinase we know uses ATP, and thio is going to represent the SH group on the CoAsh that we added. Looking at the product, we also know that we will get a acetyl-CoA as our product, as one of our products. The next step in beta oxidation is to transfer the fatty acyl-CoA from the cytosol into the mitochondria. However, we need a little helper, and this little helper is going to be carnitine. Okay? Carnitine is going to be put onto the fatty acyl-CoA by the action of carnitine acyltransferase 1, or CAT1, which is in the outer membrane of the mitochondria. From there, this fatty acyl-CoA that we added the carnitine to, we're going to shuttle it into the matrix. This is the matrix. Through these transporter proteins. And then from there, we're going to take off that carnitine by the action of CAT2, which is carnitine acyltransferase 2. And our carnitine here that we've taken off is going to be reshuttled back out and reused to bring in more fatty acyl-CoAs into the matrix, where beta oxidation is going to occur. And our fatty acyl is going to be returned to its fatty acyl-CoA structure. So now that we have undergone our activation of the fatty acyl, and we have put our fatty acyl-CoA into the mitochondrial matrix, we can now undergo beta oxidation in the matrix. We're going to start with a fatty acid that has 16 carbons. And our first step is going to be oxidation, for beta oxidation. How can we tell this from the structure, though? Well, our alpha and beta carbons, that is the first and second carbons from the carbonyl group, are going to lose 2 H's. Losing 2 H's means it's going to be oxidized, and we're going to have a double bond. The 2 H's are going to be gained by FAD, and it's going to become FADH2. FAD was reduced. We know that FADH2 is going to go into electron transport chain and yield 2 ATP. We're going to talk about the energy yield later. Then our second step is going to be a hydration. We're going to add an H and an OH across that double bond at the alpha and beta carbons. And here we can see the OH, and the H is right here. So after we hydrated in the previous step, now we're going to oxidize it again. That means we're going to lose H's from the alpha and the beta carbons, and those H's are going to be added to NAD+, and NAD+ is going to be reduced into NADH. After our oxidation, now we're going to undergo thiolysis. That means we're going to add a CoAsh to break apart that acetyl-CoA and have our remaining fatty acyl-CoA. We know that acetyl-CoA can go into the TCA cycle and yield, just like in glycolysis, yield energy. Our remaining fatty acyl-CoA, we're going to continue to break down into acetyl-CoAs, and I'm going to explain the energy yield in a second. So how much energy do we get from beta oxidation? Well, let's look at the example we have been using of the 16-carbon fatty acid. How many acetyl-CoAs do we get per 16 carbons? Well, if acetyl-CoA has 2 carbons, then we just divide by 16. That's going to give us 8 acetyl-CoAs. How many rounds of oxidation do we need to undergo to get those 8 acetyl-CoAs? Well, a little trick is to look at the number of acetyl-CoAs and just subtract 1. That's going to be 7. Why? Well, because the last step is just going to be breaking off those 2 final acetyl-CoAs, and so we don't have to undergo beta oxidation for that final acetyl-CoA or that 8th acetyl-CoA. It's just going to come out of it. And then another little trick is when we're asking how many NADHs and FADH2s we get, we just look at the rounds of oxidation. We have 7 rounds of oxidation, then we're going to have 7 NADHs and 7 FADH2s. So how many ATPs does that give us? Well, we know from the TCA cycle that 1 acetyl-CoA is going to give us 12 ATPs. So 8 acetyl-CoAs is going to give us 96 ATPs. We know that 1 NADH is going to give us 3 ATPs. So 7 is going to give us 21 ATPs. And we know that if 1 FADH2 gives us 2 ATPs, then 7 is going to give us 14 ATPs. That's going to be a total of 131 ATPs. But we recall from the first step of fatty acid oxidation, we activated that fatty acid and made it fatty acyl-CoA. We used 2 ATPs, right? So we have to subtract those. And then we're going to get a grand total of 129 ATPs for our 16-carbon fatty acid. So, does beta oxidation give us more or less energy than glycolysis? Well, if we look at it, if we divide 129 per 16, that's going to be 8 ATPs per 1 carbon, as opposed to glucose, which is going to be 6.3 ATPs per 1 carbon. So beta oxidation is going to give us more energy per carbon than glycolysis. So let's do another example for practice. Let's say I have a 20-carbon fatty acid. How many acetyl-CoAs would I get? Well, simply we just divide it by 2. That's going to be 10 acetyl-CoAs, right? And how many rounds of oxidation are we going to undergo? Well, we just do 10 minus 1. It's going to be 9 rounds. And that tells us how many NADH and FADH2s we get. So it's going to be also 9 NADHs and 9 FADH2s. So if you're given a question on how many ATPs you get or how many rounds of beta oxidation you have to undergo, you simply need to figure out the number of acetyl-CoAs you get, and from there you can just do the multiplication I showed you and figure out how many ATPs we have. Don't forget to subtract the 2 ATPs you use to activate that fatty acid into a fatty acyl-CoA.